probably when you left out here yesterday, you probably didn't look at this anymore. Let's just be honest. Just by kind of perusing through things, kind of looking at stuff. So we go some blank pages. So we're what, Wednesday? 9/25, right? The 25th of September. So we're going to finish up with tangent. We're going to graph that. Then we're going to get into graphing sine and cosine. And we're going to look at amplitudes, and we'll look at periods. Okay? It's easier to do those two together than it is to throw all three of them. So we'll attack those two, and then we'll kind of look at the tangent by itself. It's a little bit easier. So I'm more curious about how you graph this. So I'm looking at some of your papers, and I'm seeing things that look like, basically, they look like sine and cosine, and that's not correct. Because when we left out of yesterday, we said, what does it mean to be undefined? What does that mean there? It does not what? It does not exist, right? It's undefined. Okay? That means what we have at those locations are called what? What do we call those? Come on. Yeah, it's what you told. Asymptote. There you go. Ah, you remember it. See, it's a play of words, right? So there. So first things first. If you don't do this, you will probably mess up the tangent. Okay? So we've got asymptotes at who? Who do we got asymptotes at? Pi over 2 and 3 pi over 2, right? Yeah? I'm going to do this, kind of move this over. Just, yeah, that's good right there. All right, so there, I've got asymptotes drawn there, right? So guys, I can't go past those. Everything that's in here has got to stay in here. It's kind of like putting up fences and putting cows in it. The fences keep the cows from going anywhere, right? Well, these asymptotes here keep the tangent from going further. You understand? So I'm going to put another one right here. Okay? Right off the bat, is there something that you can tell me about a tangent that's different than the sine and cosine? Because we looked at a couple of things yesterday, right? We wrote them down. We talked about it. So what is different with a tangent right now compared to the sine and cosine? The pattern stops. Well, the pattern continues, but it doesn't, it's not a continuous, right? It's kind of like you got to stop, get off, walk, and then get back on the ride and keep going, right? Because the ride didn't exist in certain places, correct? So it's kind of like that. What were the two things that we called out yesterday on sine and cosine? What were they? Period and amplitude, right? So we're going to look at it here. So we're going to look at the period, then we'll talk about amplitude, all right? What is the period for this tangent? What is it? One what? One what? 1 pi. Negative pi over 2 to pi over 2, pi over 2 to 3 pi over 2 is how many pi's? Well, I could just put pi there, but I'm going to put 1 pi so that you understand it's 1. Okay, your question was, why is it not 2 pi? Well, here, let's graph them. So we got 0, 0, right? And that, we got 1. So what would we'll make this? What did you make your y scale at? Did you go a half and 1?
Yeah.
Okay. All right, we'll follow suit. And then it's undefined, right? And then this one, it's at what? -1, right? then it's where? 0, and then where? Up at 1? Yeah? Okay, so let me kind of do this. Move this right here, reference over to the other side. There. Put that there. Ready? You know what a cubic function looks like? It looks like this. Like that? Okay. So that's my attempt to draw that. So let me back up, see if I can't get that. There. Yay. Okay. Now, so I've got these points and I backed up and did this point. So do you see how the pattern repeats only at pi increments? So its period is, what is the distance it takes for the pattern to repeat, right? So that's what period is. So that's why it's 1 pi. Okay? Any questions? Yay or nay? What do you mean, not a line? Why is it not a straight line? Well, because we only looked at it in quarters, right? If we went to 12ths, pi over 12, and looked at it, then we would have these points that are down in here. That would be down in the knee of the curve. Okay? We would have a more to pi. It's kind of hard to show that with quarter increments. 12ths, you can knock and rock and roll all day long to see what the clarity. But that's what it looks like. Okay? Questions? So guys, what is my amplitude? Would it be half? No, it wouldn't be half. What would be my amplitude? My amplitude is from the highest point back to the midpoint, right?
1.
So what would be my amplitude for a tangent? 1. It only goes 1 high?
Infinity, because it keeps going up.
So does a tangent have an amplitude?
Infinitely many.
Does it have a defined amplitude?
No, undefined.
Well, no. It goes up. It continues up forever, right? You understand?
Yeah.
And it continues down that way. So from negative infinity to positive infinity, right? So there's not like what we said, amplitude 1 on the others, right? Because that's as high as it went. Yes?
Yes.
Okay, good. Bless you. All right. Any questions on this? Do you see how I drew the asymptotes? How it made drawing the tangent a little bit easier? So the first thing, if I ever got to a tangent that had the graph, the first thing I would be doing is, where is it undefined? Because I'd be drawing them asymptotes first. Then it's a matter of what does it look like, right? Okay. All right. Any questions on this? So in your hands right now, you have sine x, right? Or sine theta. Sine x and sine theta, same thing. You've got cosine, and you've got tangent. So you have the parent functions for all three that we're going to look at, right? Not going to look at the reciprocals, other than this is what they look like. Fair enough? And we'll graph some. I'll show you some stuff, and I'll get you to do some stuff on the graphing calculator as well, which is pretty cool. Because you can do all of this on that.
So,
We're going to leave it blank for right now. But amplitude is how high it goes up before it starts to come back down, right? So you treat amplitude kind of like a maximum and a minimum, right? So does tangent have a maximum or minimum? Negative infinity and who? Positive infinity, right? So we're going to kind of, we'll leave that kind of gray for right now. But that's really what it is, all right? All right, so let's talk about this, and I want to go here first. Bless you, bless you. All right. What did we say amplitude was?
How far up it goes.
Right? How high or how what?
No.
Do you think the amplitudes, when you say how high or how low, do you think the amplitude should be the same? As far as the amount that goes high compared to the amount that goes low. Why? No, you're right. You're exactly right. But why? Huh? No. Look, guys. There's a sinusoidal wave, right? It's got an amplitude, right? That amplitude is going to be where? From the what? Or from the what? So in science, you looked at waves and you said crest and trough, right? Yes, crest is up top, right? Trough is in the what? Uh-huh. Maximum and what? Mountaintop and valley. Oh man, it comes back, doesn't it? So now, amplitude, listen, when you find the amplitude, for example, let's say y equals a sine yeah, I've been doing my theta a little bit neater than that. There, theta. All right. So all this right here is notes. All of this that I'm doing right now is prefacing today's lesson. So everything I got up here, you need to make sure that you have as well, right? Okay, that's very important. So amplitude is how high or how low. So we talked about, you know, from the science standpoint, you talked about the crest and the trough, right? The maximum and the minimum. So we'll turn it back into mathematical terms. Now, the amplitude in an equation is the absolute value of A. That is the amplitude. It's the absolute value of A. Anybody have an idea of why it's the absolute value of A? Anybody? Well, let's think about, you know, math has a lot of relationships in it, right? So let's think about quadratics real quick. A on a quadratic is the first rate of change, right? Correct? Now, A could be positive or what? Right. But we look at it in terms of the absolute value, right? Correct? Okay. The amplitude, because see, the quadratic could open up or it could open what? Down. A sine could be inverted or plane. It could be flipped, right? Or it could be start and go up. It could start and go down, or it could start and go up. Depends on if it's been basically reciprocal or reflected, right? So that's why we look at it in terms of amplitude is the absolute value of A, right? So let's look at the period. Period. Man. Is what? It's this. How far does it take one cycle? Well, normally, look at your unit circle. How much is one cycle? 2 pi. over, well, the b, which would be the coefficient, right? Okay, because theta could be x, right there. The theta could be x, or it could be a particular, excuse me, radian measurement. But the period is 2 pi over b, right? If the b is greater than 1, then it gets there that many times quicker, which means it's going to be shorter, right? If the b is less than 1, then it's going to be what? Kind of elongated, right? Does that make sense? Did that? Yeah? Okay, so that's what we're looking at. And the period is basically how much or how long it takes for the pattern to repeat. It's cyclical. Say that 5 times fast. I can't get my mouth. Cyclical, right? It's a cyclical pattern, meaning there's a cycle to it, right? Okay? All right, so everything that we're doing right here is everything we need for the day's graphic. You ready? You sure? Okay, so here's what we're going to do. You've got a piece of paper, right? Up here, right? So you got number 1, correct? So there's 2 things I need for you to find on number 1. And that is the amplitude and the period. Okay? So find that now and come get a graphing calculator.
Why do you have to find the amplitude?
I want you to find the amplitude and the what?
Period.
Period. Right? So, ladies and gentlemen, what is the amplitude?
The absolute value of 1.
It is the absolute value of 1 over 2, which is what? Positive over negative 1/2? No. Yes, ma'am. When you take the absolute value of a number, you always return a positive. Why? What is the absolute value of something? What is the absolute value of anything?
Positive.
It is positive, but why? Why is it positive? By definition, what is the absolute value? The absolute value, listen to me, is the distance from that point back to 0. It is a distance, and what can never ever be negative? Distance. So no, it can't be positive negative 1/2. It is basically, the amplitude is 1/2, right? You with me now? All right, good. Now, what is the period? The period is 2 pi over 2, which is what? Okay, so what do we really do to our basic cosine function? We just done what to it? Its regular period is how big? 2 pi, right? What did we just did? We got to it, we just done a period twice as what? Fast, right? Yeah? Okay, good. So let me show you some stuff. Let's go to, let me drive and then I'll let you drive. Fair enough? Huh? Okay, good. Because in this activity, you get to see my screen and you get to see the keys that I press. So if you're like, oh snap, I look down when he punched something and what happened, and then you look up and I'm like somewhere else, and you're like, what did he hit? Here it is, right here. Okay? So make sure that you are good with that. So I'm just going to clear my screen, period. There's one thing that we need to check, because when we're going to be graphing, we're going to be graphing in radians. So the one thing that I need to check is to make sure that we're in radians. And that's hit mode. You see that little mode button right there? If you hit that, about the 4th line down says radian or degree, right? You need to make sure that your radian, move it down by the little arrow key. You should make sure that it's solid, or I should black thing, around black rectangles around the word radian and not degree. Now, if it's the black little rectangles on the grid, all you have to do is move it over to the radian, and it's flashing, and hit enter. Boom. It'll switch it, right? You all understand that? So is everybody's calculator in radian mode? Okay, now, here's the really cool thing. There's really one keystroke that you need to make sure you understand that will get you out of any kind of fits, and that's this. Second mode, because you look at the word right above mode, it says what? Quit. And the only way you get to it is by hitting the second button. Now, it doesn't matter how crazy far deep down you go in this thing, you're like, oh snap, I need to get out of here. Second mode. Okay? That's like your escape button. Okay? Now, you ready? So let's just hit y equals. Am I on y equals? Now we call this the equation editor. Okay? Because guess what goes in these? Equations. So we're on the cosine function, right? So what we're going to do is we're going to hit the cosine function, and then we're going to hit the xt theta n, which is to the right of the green. And then we're going to close its parentheses, okay? So we're going to hit cosine, then we'll hit the xt theta. That is right above apps and below mode, right? You see that? That's what gets you a variable. All right? Any questions on that? And I close my parentheses. Does yours look like mine? Great. Now, let's go do some stuff. Because we want it to look pretty when we graph it, right? Ready? So, let's go to window. Window is right there. Now, so let me tell you about window. Window sets up the parameters of your viewing screen. There's a lot of functions that you can hit that change it automatically or have presets. Okay? So what we're going to do is we're going to tell it, we're going to set our domain. We're going to set where we want to see. Fair enough? So what we're going to set is this. Our X bin we want as 0. So you hit 0 and arrow down. We want our X max to be 2 pi. Now, you were Palmer, how the heck do I put 2 pi in? You hit 2, and then you hit the blue button second, and that carrot top or house top. Okay? And that's what it should look like. You see? Okay, now right now it says 2 pi, right? You with me? Now what happens when I do this? What did it do? It gave me a numerical reference, right? Yes, ma'am. You've got to understand that when you hop off of it, that's what numerically what 2 pi is, right? Remember, pi is an irrational number, which means it never ends and it never what? Repeats. Good job, David. Now, our X scale. What did we have our X scale? Those little tick marks on our. What did we have on our graphs? What were our X scales? How did our X's go up? No, ma'am. They went up what? Pi over who? 4 quarters, right? Did they not? Yes. So look at your graph that you got right here. How is it going up? How is its X scale? No, ma'am. X scale. Is it going up by halves? No, it's not going up by halves. It's going up by what? No. Quarters. The line, you can barely see it. Okay, so here's a clear indicator. Let me show you. Okay, the lines on here didn't copy as good on your paper. All right, so understand that. 1, 2. The scale on your X and Y for these graphs will be, for this that I'm using, will be the same if it come off a worksheet. Do you understand? So these are going 1, 2, 3, 4. It's gonna, you're gonna have grid lines like that. Does that make sense? If they're like grid lines going up, then those grid lines still exist going left to right on the X-axis. So you don't see it, but it's actually fours. So what we're going to do, the x scale is, we're going to say pi divided by who? 4. Fair enough? No, ma'am. Nope, because it's one operation, is it not? So there's no way to worry about PEMDAS. All right, so look at my Y min and Y max. I don't know what yours says, but for mine, I put -2 and what? +2, right? And I put a scale of what? 1. So every tick mark on that y-axis will be 1 unit. So you need to make yours look just like mine. Now, there's 2 things that you do not, or 3 things that you do not touch. You do not mess with X-res. You do not mess with change in X. You do not mess with trace step. Okay? Those are settings far above and more complex than what we'll get into. All right? We're going to use the KISS method. Keep it simple. Okay? Anybody not good with what we see right here? Anybody?
Like, so you said not to worry about it, but my X thing after express.
Okay. It's, yes, 1, 2. Don't worry about it. Y scale is the last thing that you'll touch. Okay? There's not the 3 things per axis. Min, max, and scale for X's, min, max, and scale for Y's. That's it. It's the only thing we'll touch. Now we're going to hit this thing called graph. Hit graph. Top right. Does yours look like mine? That's pretty cool. Mine's in color. Isn't it? That's shook, right? That's so shook. And I can change its color. I can. No, yours is monochrome. Sorry. No. All right. Any questions about this? Okay. The amplitude for a basic cosine function is 1, right? Well, look where it is. 1. And then how far did it go down here? -1, right? You with me? Okay. So let's do this. The first function that you have on your sheet, let's graph it in the calculator. So let's go back to y equals. Let's go down to y2. And I need you to type in exactly what is there on number 1. Do you understand? So, yeah, you can put 1/2 in parentheses. So, 1 divided by 2, okay? You need to do that because if you don't, it may look like it's 1 divided by 2 cosine of something, right? So, and that way you've got it beyond a shadow of a doubt that this is going to work, right? And it's 2 what? X and then parentheses, right? Does mine look like yours? Yes or no? All right. Are y'all good? Now, let's go back and look at something real quick. We said that the amplitude should be what? Hey, right here. Amplitude should be what? 1/2, right? The period should be what? Pi. Yes? So it should get there twice as fast, right? Yes? Normally it takes 2 pi. It's going to get there by pi, right? That's twice as fast. Correct? So here's what I want to do. I want to go to graph. I want to go to window. And here's what I want to go to window for. Because we have an amplitude of 1/2, right? So I would like to change my Y scale to be 0.5. Is that okay? So now I'm going to have a tick mark at every half, right? Does that make sense? So what I'm looking at, I can visibly look at the screen and be able to understand that that's 1/2, that's 1, that's blah, 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 right? Yeah? Okay, y'all ready? Yes or no?
Yes.
Hit graph. Huh? You got 1/2, 1/2 cosine. That's your problem. So okay. Did it look right here? Each one of these are pi over 4, right? Pi over 4, pi over 2, 3 pi, what? Pi, right? Did it complete a cycle in pi time?
Yes.
Yes. How high is its amplitude? 0.5, a half, right? Okay, so if its period is pi, where do you think its midpoint along the travel would be? Because see, a cosine starts out up here, and it goes down, then it goes back up, right? It's like the first drop on a roller coaster, correct?
Yes.
Yeah? It's like over there. It's like, you got that little flat spot at the top. You know what I'm talking about? And then it's what? Shoom, right? Okay, so it's your first drop, right? And then it comes back up, right? I mean, yeah. How do you think they got this done? So, look. So, in a regular cosine that has a period, that's the blue one, it took 2 pi, with half of it being pi, right? Now, we just changed the amplitude and the period. We made it get there twice as fast and cut the amplitude down to half of it, right? So, it got, here's cool. This is pretty cool. Watch this. You go over here. Yeah, you're going to see it. You're like, it's cool. No, it ain't. La da da. Ha. That's pretty cool. Because look what I just did. All right. You ready? So, man, let's do this. So, you see its period right there? Hey, you see its period for this? It stopped right there at pi, right? So what's half of the distance? What's a half of the distance of pi? What's half of pi, guys? Pi over what? 2. Good. So does it make sense? Hey, nothing y'all talking about is more important than what I'm talking about right here. Does it make sense that at the trough, at the lowest point, the minimum, that it's negative 1/2 at what on the x value? Pi over 2. It's half of the period, right? That's where that transition point would be, correct? Now for cosine, you would take that and split it up into 4s because you got a peak, a middle, a valley, and then back to the middle, right? See what I'm saying? So that's some things that you've got, if you think about it and understand it, graphing becomes much easier. All right? So here's what I want you to do. On your paper, graph. Huh? No, just that. I put the other one up there for you to just to visualize it, right? All right, hold up. All right, hold up. This is what I want you to do for tonight. You have how many graphs on there? There's 8. How many of them are cosine? 4. There's 4 cosines. So I want you to find the amplitude, the period, and I want you to graph. You got 4 problems, that's all you gotta do. You understand? Yes? Okay. Good luck. Have a good day.